What do we know? I want to share some stories about how we say no and yes to thinking in the math classroom. And the first story is set in a 9th grade Algebra 1 class. The students are repeating Algebra 1. And the teacher has asked them, and I'm collaborating with the teacher, to say what they know about linear relationships. And the student says, constant rate of change, y-intercept. The teacher writes down rate of change, slope, y-intercept. The student says, what about exponentials? The teacher's going, what about exponentials? Well, don't they have a rate of change? And the teacher's looking at me and saying, well, I say, wow, that's a really interesting question. So what are you noticing? And the student says, well, it changes, but it's not constant. And then we go off and we have this very interesting conversation about curves and lines and talking about how we can use the lines to think about the curves. And the teacher is telling the story recently, and she said, did you notice how all the students turned and were riveted by this conversation? So what was going on there? It started out as this moment of knowing, right? What we know about linear relationships. And then there was this moment of thinking in the crack there. Constant rate of change, rate of change. And then our question sort of rescued us before we said no. What are you noticing? All right, second story. 6th grade teacher is doing Notice and Wonder. It's our bread and butter strategy for engaging students in thinking. And she's noticing that the students are doing less and less thinking. She watches herself on the video and realizes that every time she's restating what the students are saying. So she turned the activity from an activity of student thinking into an activity in which the students are trying to figure out how close they can get to the teacher's words. They may not even recognize they're thinking anymore. So we can say no to thinking even when we're trying to say yes to thinking. All right, so let's go back to the 9th grade linear equations. They're trying to figure out how to write an equation for the cost of a taxi ride. And they're doing a lot of explaining, but they're not actually showing their calculations. And there's a lot of different answers and confusion. And it goes on for quite a long time. At the end of the process, one of the students in the original group says, you know, there was something fishy about this answer. I could tell that we weren't going to get the results that we should have gotten. And we said, well, you know, there have been a lot of times when recently you've been noticing fishy things. They say, yeah, well, we should put a star down every time we do that. Starfishies. Starfishies is a custom tool for thinking about thinking. All right, so what can we do to really focus on this idea of saying yes to thinking? Problem solving is a natural place to do it, right? It's where we think about the mathematical practices. So I want to put a problem up here that students are thinking about, and we'll look at it and then try to figure out how we say yes to thinking. How many bricks will it take to finish the square section of a walkway? So students might be looking at this, and some of them say, I don't get it. This problem is hard. What do we say that's a no responsive thinking when they do that? Well, we might say, what if you just focus on this corner? Oh, you mean I should count the bricks here and then I can use it somehow? We asked a question, but what we're really doing is offering our own idea. We're not asking about the student's thinking. What if instead we said, oh, this problem's hard? So what are some things about the problem that make it hard? It's not finished, there's so many different shapes, take forever to count it. Don't you have a simpler problem? Oh, so you could solve this if it was simpler? Well, yeah. Well, what would be an example of something simpler here? Well, I can tell you how many are in this corner, and then, what I want is a question that follows the student's thinking and is interested in the student's thinking. All right. So, last story. What do students take away from this? From the first one, they might take away, what I need next time is just someone to show me the right place to start. What we're hoping they're going to take away from the second one is, can I remember to ask myself, what makes this problem hard, and can I think of simpler ways, simpler problems here that I could work on? So I come to an 8th grade class where some of our other folks have introduced Noticing and Wondering, and I'm sitting down with a group, and they're doing a great job generating all kinds of Noticing and Wondering. And I'm excited for them. And I say, you guys are doing a great job. It looks like you've thought of some ways to start solving some of these problems. And they say, wait, we're not done Noticing and Wondering. I go, I can't believe I just did that, saying no to their thinking. I just did that. And later I checked with the teacher, and the teacher said, yeah, somehow they figured out right away that if they did a thorough job of Noticing and Wondering, they would be able to think about any problem that came out of this. So, fortunately, these kids could recognize a no when they heard it, and they had a strategy of their own that they owned where they could learn to say yes to thinking. Thanks.